So we're in the home stretch now. Let's go ahead and set up the UI. So let's create a new scene here. This is going to be a canvas layer. And we can name that UI. So canvas layers are used for things like heads-up displays and UIs where no matter if our game camera is moving around. I mean, in this game, we're not moving the game camera around, but if we were, a canvas layer would make it so that the UI is staying in the same place on the screen, even if our game camera is moving around. So that's what canvas layers are used for. Let's create a margin container here. And let's come up here and set that to full rect. And come down here to the margins, and we'll set a 8-pixel margin all the way around the edges. We don't want our UI right up on the edge. So this will give us a little buffer around the edges. And whenever you have a container or a controller, anything that's covering the entire screen here, you want to make sure to turn the mouse filter off. So here's the mouse filter here. Let's turn that to ignore so that mouse clicks will be able to get through your UI. So we have a margin container here. Let's add a VBox container under that. And let's set that to shrink end on the vertical. So this will be at the bottom of the screen here. Let's add an HBox container into that. And then let's add 2 labels into this HBox container. So the first label is going to be our score label. And the second label is going to be our time label. And so under here, we can start this off just saying time 999. And this score label, we can set this to saying score 99999. Let's click on our HBox container here, and we want this time label to take up the entire HBox container. So to do that, let's click expand here. Sorry, not on the HBox container, on the time label itself. Let's come down here and let's have this be on the horizontal, shrink end and expand. So that'll make sure that it expands all the way to the other side of the screen there. Now under our VBox container again, let's have another HBox container. And this is going to have 2 more labels inside of it. And so this is going to be the high score label. And this is going to be the lives label. And so here we can put high score. And for lives, we can do lives 3. And we'll do on the horizontal, shrink end and expand. So there we go. Now let's create under your resources folder here. Let's create a new folder here. This is going to be called themes. And let's create a theme in here. So let's do a new resource. This is going to be a theme. And we'll name this UI theme. So we want all these labels to use the same font and the same look and all that. So instead of doing those individually, we can just set up a theme and then assign a theme to all these labels, and they will all look the same. So let's click this plus button here and type label. We want to set up a theme for our labels here. So for the font shadow color, let's click this plus button to override that, and we'll have it be full black. And turn the alpha all the way up. On the shadow offset X and Y, let's leave that for now. Under font, let's override the font here. And let's select our monospec.tff. And let's come to our UI canvas layer here. Can we set a theme straight on this? Doesn't look like we can. So let's do the margin container. That's the highest container that we have, and we will assign our theme on this, and it'll apply to everything underneath it. So where did we put that in? Right here under theme. So drag and drop that in, and it applies to all of our labels now. Our font shadow color, our shadow outline size. Do we want to change this? Yeah, let's make this font, this shadow outline size. Let's hit the plus here, and let's make this 5. So it's a thicker outline. Okay, there we go. All right, let's go ahead and save that. Under source, make a new folder, UI, save that UI scene in there. And let's go ahead and add a script to that. Okay. So for all the signals that we're going to use for connecting the UI up to the points and the lives and all that, I like to use a signal auto load, an events auto load that holds all of our signals. So I wouldn't want to put all of our signals like on the game, anywhere else other than that. It's just easier to access them if they're all in one place. So under our autoloads folder here, let's create a new script. Let's name this events. And then go up to projects, project settings, under globals. Let's add that events script as an autoload here. So now we have the events autoload. We can access this throughout our project. And double click on that events.gd. And let's add all our signals in here that we're going to use for the project. So let's have a signal level complete. Have a signal game over. Have a signal score changed, and we will pass in the score. Have a signal high score changed. We will pass in the high score. And let's have a signal lives changed. We'll pass in the lives. And let's just make this look nice. Just have a comment here. These are going to be the game signals. And these are going to be the UI signals. And so it's giving us a warning here saying that we didn't use these signals in this script. but we're not going to be calling these signals within the script. The way we have this set up, we're never going to be calling these signals from the events.gd. So just to get rid of this warning, let's go to project settings here under general, and we'll search unused signal. And we'll just turn this warning to ignore. Okay, so we have some signals to play with now. So let's go back to our UI script. And in here, let's select all of our labels and access these as unique names and drag and drop them in. And statically type them as labels. And let's come into the ready function here. We're going to connect to all those signals. So events.scoreChange.connect to onScoreChanged. Copy that 2 more times. So this is going to be events.highScoreChanged to onHighScoreChanged. This is going to be LivesChanged on LivesChanged. Do this 2 more times. Connect to level complete to on level complete and game over to on game over. So let's create those functions really quick. So on score changed, this is going to take in the score. Let's have high score changed. It's going to take in the high score. And then on lives changed, it's going to take in the lives. Let's also set up these other ones. So on level complete, this isn't going to take in anything. And then on game over. So let's have a couple helper functions here. Let's have update score. It's going to take in the score. It's going to set our score label dot text equal to score plus a string of the score. And let's do the same thing for high score and lives. So update high score. It's going to take in the high score. It's going to set our high score label to high score with the high score, and then update lives. Going to take in lives and set our lives label to lives plus the lives. And let's have one more here for updating the time. So update time. It's going to take in the time as a float. So this is going to set our time label to time plus Let's do a %02D. So what this is going to do is it's going to take whatever variable we pass in using the percent sign here. So we're going to pass in time into this variable here, and we only want it to display the first two number slots, and we want it to be an integer. So if we put F here, this would make it a float. If we put D, that's going to turn this time into an integer. So we don't have a decimal point at the end. Okay, so that's the start of our UI script here. We need to set up game logic now. So we're going to create another auto load here. This is going to be the game_manager script. So in here, and actually, I want this to be a scene. So let's create a new scene here. Let's name this game manager. And we can just make that a node. So this game manager scene, let's add a timer under here. So this is going to be the game timer. And then we'll add another timer. And this is going to be the start delay timer. Yeah. So the reason I want this auto load to be, and then we can drag and drop that script onto the game manager node there. So the reason I want the game manager to be a scene instead of just a script is because I want to add some extra nodes underneath it, and we could add these in code, but it's just easier to do it this way. And so we can add this auto load, and make sure you auto load the manager.tscene instead of the script. Make sure you open the scene itself. And actually, whenever we have like a globals and we're just doing the script, the game actually makes a node and adds this script to it, and then adds that node to the scene. So even though we're adding the scripts here, the game is Godot is making a node and adding the script to it in the back end anyways. So all auto loads are actually nodes, or actually scenes in the end anyways. So now we have our game manager here. This is going to handle all of our game logic. So at the top here, let's have a const, let's have a save file path. And it's going to be a string equal to user ://game.save. So what this is doing is it's going to the user folder that Godot assigns, and then we're going to name our save file game.save. And to find this user folder, you just come up to project here and open user data folder. And so this folder here is actually where we're going to save our game. And you can find it's under app data, roaming, Godot, app user data, Frogger 2. This user is just shorthand for this folder here. So let's have a var lives int equals 3. We'll start at 3 lives. Let's have a score int equals 0. Let's have a high score. Let's have a lily pad count int equals 0, and a start delay. as a bool equals true. So let's come in here. Let's select both of these, access as unique name, drag and drop these timers in as on ready vars. And let's come into the ready function. And right at the start here, we're going to load our save file. Let's create that function, load save file. So if file access dot file exists on our save file path is false, then we're just going to return out of this. We don't have a save file. Otherwise, we know the file exists, so we can do var file equals file access dot open on the save file path with file access dot read permissions, and then we can do high score equals file dot get var. We're only going to save a single variable into our file. So if we do file get var, it's just going to grab that single variable, which will be our high score. And when the game starts, we will set our high score to whatever is in the file. So that's good. Let's come up here to ready again and connect to some signals. So events.highscore changed. Dot emit, actually, we don't need to connect there or emit high score. And actually, we don't need that in ready. We can do that in load save file. So if we actually got a high score, then we can emit that the high score has changed, and then the UI can update from there. But here, let's connect to some signals. So events.level complete connect on level complete, and events.gameover connect to on game over. Shrink this down so we can see more. So let's create those functions really quick. On level complete. We'll just put pass for now. And on game over. And pass. So we have a load save file, but let's have a save as well. The var file equals file access dot open from our save file path, and we will open it with file access dot write permissions, and we'll do file dot store var high score. This is a really simple saving and loading file system. We're just storing a single var, and we're just getting a single var. Let's have a couple helper functions here. Have update score, and it's going to take in a number. So do score plus equals that number, and then events dot score change dot emit, and we'll give it that score. Do update high score with a number. High score plus equals that number. Do we want plus equals? Yeah. Events dot high score changed dot emit the high score. And let's do update lives. Say lives plus equals that number, and events dot lives change. dot emit. Give those lives. And also under here, we'll say if lives is equal to 0, that means we have a game over. So events.gameover.emit, and then we will call reset game. So we'll create reset game here. Let's do function reset game. Say if score is greater than our high score, it means we have a new high score. We'll set high score equal to score, and then we will save. And then we'll do events.highscorechanged.emit with that high score. So that way we can save our new high score. And then we will reset our lives back to 3. We'll reset our score back to 0. Reset our lily pad count back to 0. And we can call events.scoreChanged.emit that score and events.liveschanged.emit the lives. Okay, let's come back up here. We need one more helper function here. We're going to do function update lily pad, the number. We'll say lily pad count plus equals number. We'll say if lily pad count is equal to 5, then we've completed the level. So we'll do level completed. So let's create that function. Function level completed. We will set the lily pad count back equal to 0. We will update the score. So we'll give them 1,000 points for completing a level. And then we will do events.levelComplete.emit. And let's cut this function out here and put it below the public functions. We'll put it below save here. So the order you always want, you want the built-in Godot functions at the top, then you want all your public functions, the ones that don't have an underscore in front of them, you want them next, and then you want your private functions after that, and then you want all of your signal connections below that. So let's click on our game timer here, and we'll set the wait time to 600 seconds and turn one shot on. So when you start a new game, you're going to have 600 seconds to beat the first level. And for our start delay timer, let's have a wait time of 4 seconds, and we'll turn one shot and auto start on that. And this start delay timer is going to be we're going to freeze Frogger in place for the first 4 seconds of a new round to give the obstacles time to spawn in and populate the map before Frogger runs across. Otherwise, we can just run across instantly and none of the things are spawned in yet. So we're going to freeze Frogger in place for the first 4 seconds before we allow him to move. So we haven't built that in yet, but that's what this start delay timer is for. So we have those timers set up. Let's go ahead and when the level is complete, let's do game timer.wait time. Actually, let's stop the game timer right there. And then we'll do game timer.wait time minus equals 30 seconds. So each round, each new level, they'll have 30 less seconds to complete. So let's do start delay timer.start. And then we'll do start delay equals true at the start of a new level. And then on game over here, we'll do game timer dot stop. We're going to need to set the game timer dot wait time back to 600 seconds. And then we can do start delay timer dot start and start delay equals true. Also, let's connect to the timeouts, the game timer timeout here. And we'll do game timer dot stop. I mean, it should already be stopped if it's timed out, but yes, we actually don't need that because it'll already be stopped if it times out. We'll just do events dot game over dot emit, and then we will reset the game. And on the start delay timer timeout, we will set start delay equal to false, and then we'll do game timer dot start. And so where we're going to use this start delay is going to be in the Frogger script. So before I forget that really quick, let's go to the Frogger script here, and right at the top of process, we'll say if game manager dot start delay is true, then we're going to return out. So we're not going to allow any inputs for Frogger while start delay is true.